Okay, so as always, we always start with a bit of background and theory, but I want to make this as raw as possible. I want to dive into a demo, but let's first look at the basics before we start with this journey. Okay, so first of all, preventive maintenance versus predictive maintenance. When you look at predictive maintenance, you perform maintenance on a fixed interval, irrespective of what your asset's condition is. And this can include routine inspections and part replacements. Now, the limitations of this preventive maintenance tactic is that there can be unnecessary maintenance spent. However, based on your strategy and your criticality of your equipment, this can make sense. If you move on to the sophisticated maintenance tactic, if you've identified your asset as critical, you can look at more sophisticated maintenance. This includes condition monitoring. This is where you use real time to make decisions in terms of your maintenance, and you only maintain based on the condition. And this prevents you from performing unnecessary maintenance, which also increases the cost. The next one is predictive maintenance, and that's what we are going to talk about in this one. So this includes your real-time monitoring using sensors like temperature, pressure, vibration sensors. It also includes analytics to gain insight into that data. And then also using advanced analytics such as machine learning models that creates predictions based on data that was trained. And this also reduces downtime. So I think it's quite important to understand this. But please, it's important to note that preventive maintenance does make sense in terms of your specific strategy that you have created for your assets maintenance. Okay, next, asset performance management. We asked this question in terms of what you understand of asset performance management, and I briefly said that there are a couple of definitions within the industry, but it boils down to you use a structured approach and tools to maximize the reliability, the availability, and the performance of your assets. And APM, or asset performance management, is typically performed on your critical assets. Now, what does this mean in the On Key world? And you have your EAM layer. This is where you execute on your maintenance plans. You've got your asset register, your intelligent assets register within On Key. But on top of this, there are a couple of other tools and layers to help you improve and extend the life of your assets. So first of all, maintenance strategy. Before you execute on your maintenance, you need to create a strategy in terms of how you are going to maintain your assets. How do you start with that? First of all, you perform a risk and criticality analysis to prioritize your assets maintenance. This is where you identify the probability of your failure as well as the consequence of that failure. So now you have a priority in terms of how you need to maintain your assets. Next, you need to understand the failures. How does your asset fail? This is where you use tools like FMEA, or failure mode and effect analysis, to identify those failure modes and identify the mechanisms, the causes, and then how to address those causes with the maintenance tasks. And ultimately, the output of this exercise is to create a maintenance plan for your assets. Now, this is where you decide which tactic makes sense in terms of, cost, performance, and risk, and as well as the criticality of your assets. And the output is a maintenance plan. Next, if you have identified a suitable, if you've identified your critical assets and you determined that predictive maintenance makes sense with your critical assets, this is where you understand and monitor the health of your assets, and you use prediction models like the remaining useful life or anomaly detection model to help you maintain that asset a little bit more intelligently. And then lastly, not just looking at the reliability and availability of your asset, but also understand the throughput and the performance of your asset, because there's a clear relationship between the reliability of your asset that has an effect on the throughput and the output or the productivity of your assets. And this is, KPIs like your OEE that looks at that. Okay, so meet Alex. Now, Alex, he's a reliability engineer, and we are going to take a journey with Alex. He works at a manufacturing company that manufactures brake discs and brake pads, and he's got a couple of KPIs and responsibilities and daily challenges, and we need to help Alex with his journey from strategy to action and understand how Alex must implement a predictive maintenance strategy within his manufacturing plant. So firstly, what is very important in terms of Alex's KPIs is asset availability. If your asset is not available, production stops. And the ultimate reliability output is availability. And it leads to the next one, reliability. So your asset needs to consistently perform without failure. Then risk exposure. So your high risk assets can lead to major financial losses and even impacts safety of staff. And then maintainability. So all reliable assets eventually fail, and it's important that you recover quickly to reduce your downtime and to reduce your costs. And then performance efficiency, like I said, you need to also understand the throughput of the output in terms of your OEEs. And then lastly, cost of maintenance. So, this has an impact on your budgets and your return on investments. And it's also quite a critical KPI that Alex is responsible for. Now, how does this journey look like for Alex? Now, we start here from strategy to action. Like I said, you need to start with your maintenance strategy. So here you start with your installed base. Now you can create your installed base with your materials, your resources, and there's a couple you can integrate your ERP if you want to also understand how your installed base should look like. And then, like I said, maintenance strategy. You need to prioritize your maintenance on your assets, and you need to understand what the criticality of your assets are. Perform a FMEA, so understand how your asset can fail, and this is typically done on critical assets. And then the output is a maintenance plan for your asset. And then predictive maintenance. So there's a couple of ways for ingesting prediction data. So the one way is a client that can host the model themselves. Either or the APM tool itself can host these prediction models. And then lastly, you can have a basic expression, a formula-based expression that can do forecast for you, where you don't have to use AI or machine learning. And I will zoom into these blocks after this. And then, like I said, from strategy, you need to execute on your maintenance strategy. And this is where your enterprise asset management tool comes in. And it's quite important that it's seamlessly integrated into your APM. Now, in terms of Alex and what he's responsible for, if an alarm is created, so let's say, for example, there's an alarm that was created, which falls under a conformance alarm, which means that if it's 3 deviations away from failure on your PF curve, it means that it's in conformance. There's no need for Alex to intervene, and that part can be replaced per instruction. But if it's in non-conformance, which means that it is before the 3 deviations away from failure, which is an anomalous behavior. And this is where Alex needs to intervene and then analyze the data to understand and gain insight, to understand what caused this anomaly, to look at the asset health, remaining useful life, analyze your time series data, and then decide should a follow-up work order be created. And there's obviously quite a few flavors in terms of this process of how you execute on your strategy, but this is just a high-level basic process diagram, but you can extend on this. And then the output of your analytics, so either decide should that be closed, and then the output can improve your install base or make changes to your install base, or you can improve your maintenance strategy based on what the outcome of your analytics exercise was. Okay. So let's zoom in into the maintenance strategy. Okay, so we've got a tool to perform that exercise of creating a score, criticality score for each one of your assets. So you capture this, so you've got a formula, and this formula can be custom, and you've got a couple of factors that bear a weight within that formula. So these factors can be probability, equipment effectiveness, cost of your non-compliance, or impact on other systems. And you have control over that formula. And how does it look like? So we capture the data on Key, and the output you can visualize to see, in those columns that looks like a Christmas tree. These are different sessions within different periods of time, and to look at your criticality scores, because factors such as the environment can also change the criticality of your assets, and it's important to frequently perform these criticality scores or scoring. And then, like I said, and then this produces a maintenance plan. So for this example, Alex created a predictive maintenance plan to say that, the primary task is that IoT data needs to be ingested into the system. And then if there's a threshold that was exceeded, that needs to create a follow-up task depending on what alarm was triggered. So, for instance, a follow-up task can be created to say that a predicted remaining useful life level dropped below threshold, and that Alex needs to investigate immediately. Okay, and then the next one is the predictive maintenance. So let's zoom in onto this one. Okay, now firstly, this prediction model can be hosted in the client's environment, and the data can then be ingested into the On Key platform using On Key's APIs. So this is where entities such as monitoring points ingest this data. You can set up thresholds. These thresholds, if the data or the readings exceeds the thresholds, alarms can be created, and then you can decide if those alarms should automatically create work orders. And the beauty of this is that you can predefine, who the staff member is that needs to investigate, the space, or the resources that are required for that work order. And this is and the demo that I'm going to present is going to be based on this model, where the clients host this model and they push the data into the On Key system. Another option is where the On Key APM system itself hosts this model, to perform the same task of ingesting the data and triggering alarms and work orders. And like I said, also is that, there's the option of also creating a basic expression that is formula-based and doesn't use ML or AI to forecast prediction, and where you can use an expression to forecast prediction. And there's a example, and this method looks at a weighted penalty method. So you've got your 100%, and then there's penalties where each factor or telemetry reading gets deducted. It's weighted and it gets deducted from your 100% score. Okay, then how does this look like in terms of our architecture? And let me start at the top. And the result or the outcome of an APM solution is that it should give you an indication of what the health of your asset is, what's the recommendation in terms of your maintenance strategy, analytics is required to gain insights, and then lastly, have a view of your maintenance plans for your assets. And how do you get that output? So there's a couple of features that support that outcome. So there's condition monitoring, your FMEA, your OEE, your intelligent asset register, etc., and then your criticality and risk assessment. Now, for an APM solution, you need to integrate into other data sources to form this clear picture, especially if, because you want to also integrate and blend time series data with your asset data to create this context. So first of all, you can integrate into your ERP to have a view of your materials and your resources. You can integrate your time series data, so your asset generated data. This includes IoT, OT or operational technology data. Data from your historian, we can integrate into your historian or your data lake. And even, like I mentioned, your machine learning model that is hosted can also then be pushed into the On Key APM world. So there's a data lake that sits in here to ingest all of that data. And then lastly, the block here to the right is the enterprise assets management platform. Now, if you already have an enterprise asset management tool such as SAP, we can integrate into it to assist with the work execution part. So in other words, your planning and scheduling, field service management, contractor management to automatically create those work orders. If alarms were created, push it to your system. Your EAM can help with the planning and scheduling. And then also quite importantly, in terms of your maintenance strategy, that will also produce a work forecast that should also be pushed into your enterprise asset management. And then the status of those work orders also need to be synchronized back into the APM platform. Okay, now let's dive into the demo. Okay, so let's say an alarm was now created for Alex, and Alex received a notification on his mobile application, and he needs to now investigate there was an anomaly. So let's first go to the alarms panel just to quickly have a view of the alarms. Okay, so here I can see that there's an active alarm that was created. I can see that there's two tasks linked to it. I can view the expression that triggered that alarm. So if I can open this up, you will notice that there's an expression that was defined to say that if that remaining useful life dropped below a specific threshold, and that threshold you can go set up and you have complete control over that. Okay, so that alarm was created. I can also see that a work order was automatically generated. And if I go to my work orders, I'll notice that on that specific asset on the belt conveyor, so like I said, Alex works in a manufacturing plant, so there's an alarm that was created on one of the motors on the conveyor system. So let's open this up. And here I've got access to the information of this work order, and then it will go through the whole work planning control cycle. But yeah, if I want to view, the tasks that, Alex should perform. So let's look at the tasks. So here, if I open up this task, this is a task that was predefined during your maintenance strategy phase. And this instructs the person that is responsible for responding to this anomaly so that they know exactly what to do. So, this is the instruction to tell Alex that, the remaining useful life value dropped below threshold and that Alex should investigate immediately. So like I said, you can predefine your planning for this task. You can set up spares, resources if you want. I haven't set up any over here, but you've got access to many different entities to have an informative work order for the person that needs to execute on this work. Okay, so that is the alarm, that is the work order that was created. And what I want to do now is Alex now needs to analyze this data, and this is the action part. So once I've presented the analytics part of this, I want to show you how this maintenance strategy was set up in On Key as well. So let's just go to the home page. Okay, now Alex, he noticed that there was an alarm that was created, and now he wants to navigate to his predictive maintenance dashboard to look at the health index, the live health index values, and he is now able to filter on a specific line. So let's say he wants to filter on line 3, and he wants to specifically look at line 3's health index for that conveyor. So he's got access to the history of the readings that were received. And then next, okay, so this one now had a orange a status link to it. Okay, so now he's got access to an interactive 3D model. Okay, and the nice thing about this is that you have spatial awareness of your assets, and you have access to your sorry, let me just, yeah, there we go. Okay, so you have access to your real-time data. So specifically here, you can look at your belt speed, you can look at your motors with remaining useful life. Yeah, so there's belt speed, real-time data of the latest data for that specific line. You can look at the latest values for each one of your conveyors, motors. And now Alex has the responsibility to analyze the data to see why this event occurred. So looking at the right-hand panel over here, and specifically conveyor 1, I can decide, what telemetry I want to look at. So here I've got the temperature and the vibration, but then I also want to look at motor currents, for example. Okay, and if I want to expand on this graph, so let me click on this expansion button. And Alex has a couple of options now in terms of interpreting this data. So you can manually look at each of these points in this time series data that was generated. But if he wants intelligent assistance, he can also look at the insights button over here to understand if there's any statistical analysis that was performed by an AI model. For example, this one over here identified a time series outlier. So there's a baseline that was created for the average of these readings, and this specific feature identified the range in terms of from the baseline, and there are 2 points that had a significant jump from this baseline of values. Okay, so this tool also helps Alex to understand and understand the data, and that will assist Alex to make more informed decisions. Okay, now let's move on to the next part. So this is the action part. Work order was created from the alarm, and Alex was able to analyze the data and make an informed decision. But let's go back to the strategy and actually show you how this was set up. Now, just to show you one of the other visualizations that we created, specifically now for the criticality analysis. Okay, there we go. So there's the screenshot that I showed you. Criticality performed, on some of the production lines, and there's a score that was linked to each one of these assets over here, with 3 different sessions that some staff scored on each one of these assets. Okay, and then like I said, you have to understand the risk and criticality of your assets. The next step is, once you've identified your critical assets, you want to now look at your FMEA, or your failure modes and effect analysis, and to expose the data that was captured in On Key visually inside the dashboard. So there's a dashboard that was created just to show exactly that, to have a nice pivot table of your failures for your assets. So here's a nice pivot table, that is grouped by the asset type, the function, then obviously the failure mode for each mechanism, and then at the end over here the task that addresses the cause that was identified. And over here I'm going to drill into the AC, or the squirrel cage motor that is on that production line, and for the alarm that was created and Alex had to respond to. Okay, so this is the visualization of the data that was captured in On Key. Now let me quickly just jump to On Key and show you how some of that data and that master data was set up in On Key. Okay, so let's go to our asset type tree. And like some of you know, this is our, let's call it our template, where you create an asset type. You've got a library of assets over here, and then you can create children of these templates within your asset tree. Okay, so let's open this up and navigate to the motor. Okay, and you can expand on this. So there are common components that can be inherited by any one of these children over here. And I want to navigate to the squirrel cage motor. So there's the squirrel cage motor. And if I expand that, you'll notice that here are its components that were inherited from above, and then also the specific maintenance task for that squirrel cage motor. But let's just open up this asset. And if I navigate to the context menu over here by FMICA, here you can see a list of all the failure modes that were identified for this motor. And if I open up one of them, I can go look at the detail. I'm not going to drill down into much detail, but see there's the failure mode, the failure mechanism, and the cause, and then obviously the task to address that cause. Yeah, so all of the data is properly captured here in On Key, and you can expose that data, and then this FMIC, or the failure data, then drives your maintenance plan within your system. Okay, and then next, what I want to show you now is the threshold logic that is set up to trigger those alarms. And in our world, we call it a monitoring point triggers. So here's the one for the conveyor, and there's the one for the motors. So let's rather open up the motors one. And you can create as many expressions as you want to trigger logic for alarms. And you can create quite complex expressions to trigger alarms. Now, for instance, if you want to apply hysteresis to avoid any bouncing of your data, where it's just creates false positive alarms, where you say that and create an expression to say that only creates an alarm when it exceeds a minimum aggregated value over a span of 1 hour. And all of this logic can be set up using On Key's query language over here. Okay, but yeah, you can set up quite complex expressions over there. But I'm not going to go into the detail of that. Okay, and then the actual monitoring points that ingest the data. So let me just also show that. And let's just filter on one of the assets. So I mentioned, line 3. And here are the monitoring points for this specific asset. So if I look at, let's say, for example, motor current. Now, motor current data was pushed into On Key using On Key's APIs from IoT solutions and sensors. And here are the readings that drives the alarm triggering mechanism. Yeah, so there's all the data that was pushed into On Key, and then those monitoring point triggers where you set up the expression logic will then create an alarm based on the readings that were received into the system. Okay, but I just want to go back. So that was your asset health section in terms of getting this data into the system, triggering alarms, triggering work orders, and then to execute and respond to the anomaly that was created. But if I can just quickly go back to my asset tree, what I also want to show you is is just the task that was set up to drive that, and I quickly showed that within the presentation as well. Okay, but here's the task. So here's the primary task that you set up for your prediction maintenance tactic, to say that your primary task is that you want to automatically ingest IoT data into your system. And this is now associated with your expressions to actually trigger the alarms. So, and you can set up your planning. So this is a condition monitoring or / predictive maintenance tactic. But then if you expand on this, if an alarm gets triggered, there's a couple of follow-up tasks that also gets triggered based on what alarm, was generated. So yes, the predictive or the predicted remaining useful life of the motor that dropped below a threshold. And like I said earlier, this is associated with that logic that triggered that follow-up task. Okay, so yeah, I said a lot now, and I went into a bit of detail, but I hope I didn't lose some of you. But I think the point over here that I'm making is that it can support all types of maturity in terms of where you are, and it can support from your basic setup, and the system is very flexible to also support very complex and flexible type of maintenance strategies for your environment and for where you are within your maintenance journey. Okay, but I think let's just jump back to the presentation. That was the end of the demo. Let's just go back to where I stopped. I hope you enjoyed the demo, but let's move on to the roadmap. So what is our immediate next plans in terms of features that we plan to develop and make available within the On Key system? So the first one over here is asset performance management. So the OEE, like I said, it's not just important looking at the availability and reliability of your assets, but also looking at the productivity and the output or throughput of your assets. Next one is routable, so repairable sub-assemblies. So this is where you need to remove, one of your sub-assemblies, and it needs to go to the repair office. And how you manage that, we will also support in the system. Next is infusing more intelligence into the system for generating ideas and recommendations and automating your tasks. Contractor management, also busy with that, and we will have this available quite soon. And then we are also further modernizing our user experience and making our tool sets more modernized and more let's call it intuitive in terms of how you use the system. Okay, and that is it.